statistics class. First of all, as far as the Chapter 10 test goes, you're not going to take a test in school on Chapter 10. Whatever you did on the online test, or if you might not have done it yet, but it should still be on there. I'm going to count that as your score for a Chapter 10 test. And we're going to go ahead with Chapter 11. Okay, 11.1, I'm probably going to split into a couple of different sections. Chapter 11 is about hypothesis tests and confidence intervals that compare two parameters. For instance, they might a hypothesis test might compare two different means. Okay, just for example, if a drug company was going to test the effectiveness of a new cholesterol reducing drug versus the effectiveness of a current cholesterol reducing drug, they might randomly select a group of patients to try the new drug and randomly select a different group of patients to use the old drug. And then they could compare the mean reduction in cholesterol between the two groups, okay, and then carry out the appropriate inference procedure for that. Now, in that case, what we would be doing was we would be comparing two means, and that's what the first hypothesis test in Chapter 11 in Section 11.1 talks about. It's I'll tell you the name of it. It is the two-sample t-test. Okay, so that's the name of the first inference procedure that we're going to learn how to do in Section 11-1. Now, we're going to start by just kind of introducing some notation. The fact that we're going to be using two different populations in our inference procedure means that we're going to have to use subscripts to distinguish the mean of one population versus the mean of another population. So that can be done just with numerical subscripts, or you can use subscripts that make sense in the context of the problem. Okay, for example, if you were going to test the effectiveness of two cholesterol drugs, you could call the mu sub n is the mean cholesterol reduction for patients taking the new drug, mu sub n, where n stands for new. And then we could call mu sub O, where O stands for old drug. That would be the mean, blah, 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 cholesterol reduction in patients using the old drug. Then, okay, we want to know if this true mean reduction is different from this true mean reduction. Well, in that case, our null hypothesis might be something like this. The null hypothesis is that essentially the mean reduction is the same for both drugs, okay? And that can be written a couple different ways, but you can't go wrong if you write it like this. Mu sub n minus mu sub O, mean reduction to the new drug minus the mean reduction by the old drug equals 0. Okay. Now, the alternative hypothesis could take on three forms. We're probably in this context looking to see if the true mean reduction in the new drug is larger than the true mean reduction in the old drug. So, we could do the alternative hypothesis, mu sub n minus mu sub O, is greater than 0. Okay. So, the steps in the hypothesis testing procedures are not going to be a lot different than they were for a one sample t-test. But of course, this time we are dealing with two different populations. So, we have to define two parameters of interest instead of one. And then our hypothesis statements are usually structured something like this. Okay, now there doesn't have to be a 0 here. Okay, there will be contexts where it doesn't have to be a 0. And the alternative hypothesis, of course, can still take on the three forms that it could back in chapter 10. Okay, now let's talk about where to go from there, though, with a hypothesis test. And to do that, we need to think about what conditions will need to be checked and such. I should say, by the way, when we're talking about the other when we're talking about sample statistics, if I want to talk about the sample mean for a new drug, I'd use X bar sub n. If I wanted to talk about the sample standard deviation for a new drug, I'd use S sub n, etc. Okay, so we'll have a lot of notation, but it'll all be distinguishable and identifiable by the subscripts that we use. Now, what I think I'm going to do is I've got my computer here and I'm clicking to an example here of a two-sample t-test, and we're going to go ahead and do a two-sample t-test here, or at least part of one. I don't want these videos to get too long. Okay, so let us set up the situation here. Okay. A set of researchers did a study on two sets of college students, one set that did use Facebook regularly and one set of college students that did not use Facebook regularly. And they wanted to know if there was a difference in the grades earned by one group versus the other group. See if one group, the Facebook group or the non-Facebook group, tended to earn higher grades. So let's just get started here. First of all, defining the parameter of interest. Mu sub f is going to represent the true mean GPA for Facebook users. And then how about mu sub n will be the true mean GPA. I'm going to abbreviate here for what I'm going to call GPA for non-Facebook users. Okay, so that's a very nice set of parameter identifications. The next step, just like it was in chapter 10, is going to be the hypothesis statements. So my null hypothesis will be that the true mean GPA for the two groups is the same. Okay, Facebook does not somehow affect a student's grade point average. So I'm going to write mu sub f minus mu sub n equals 0. Now, the researchers believed that the regular use of Facebook tended to decrease. They had reason to believe that it would decrease as that population's collective GPA. So for my alternative hypothesis here, I'm going to write mu sub f minus mu sub n. And let's think about this. That would mean that the mean Facebook user's GPA would be lower than the mean for the non-Facebook group. So if this is less than this, it would mean that this difference would have to be less than 0. Would be the correct alternative hypothesis. Now, this video has gotten kind of long, so I think we're going to go ahead and end it here. Okay. Next time, what we'll do is we're going to continue with this exact hypothesis test. Okay. So signing off. Thomas, say.
What is that?
What are you doing, Thomas?
Okay, egg on your face.
Thanks a lot, boy.
It all just fell on the floor.
And remember, subscribe to the channel Teddy Patrick.
Okay.
Goodbye.
Thomas, you're about to die.